Dear students, so let us see this question. So a heavy ball of mass 2m moving with a velocity of v0 collides elastically head-on with a cradle of three identical balls, each of mass capital M as shown. So these are capital M masses. So determine the velocity of each ball after collision. So not only one collision, successive collisions will take place. So finally we are supposed to find out the final velocity of each balls. So before doing this problem, we will assume a small gap between the balls so that very easily we can calculate the velocities after each collision. So let us see. So this is a ball of 2m. It is moving initial velocity of v0, and let it be my initial mass, second mass and third mass. Initially all of them are in rest position. Okay, so now after the first collision I can find out the velocity of this first ball by using the relation v1 is equals to m1 minus m2 divided by m1 plus m2 into u1, and u2 is 0, so the next part of the equation I can neglect that one. So therefore m1 is 2m minus m, so mass of this one is m, so divided by 3m into initial velocity of the first ball is v0. So therefore this is m by 3m into v0, so nothing but v0 divided by 3. So this is the velocity of this ball after collision. Now what is the first velocity of the first target ball after collision? That I can calculate by using v2. v2 is equals to, first of all we will write the total equation. So m2 minus m1 divided by m1 plus m2 into u1 plus 2m1 divided by m1 plus m2 into u1, this is u2 here. So this total term will become 0 because u2 is the initial velocity of this ball, which is equals to 0 because it was in rest position. Now if I calculate v2, 2m1, so 2 into 2m divided by 3m into its initial velocity is v0. So therefore m and m gets cancelled, so it is equals to 4 v0 divided by 3. So after the collision, this ball will attain a velocity of v0 by 3, and first target ball will attain a velocity of 4 v0 divided by 3. And here he gave that all these collisions are elastic and head-on collisions. So therefore in a elastic collision, if masses are equal and if the collision is elastic, then what will happen? This ball, if it is traveling with a velocity of 4 v0 by 3, it gives its velocity to the second ball and velocity of the first ball will become 0. Similarly, now this ball is traveling with a velocity of 4 v0 by 3, then it will give its velocity to the third ball and this ball will come into rest position. So after first collision, let us see all the velocities now. So velocity of 2m is equals to v0 divided by 3. This ball has gone into rest position. Second ball has also gone into rest position, and now third ball, it has started traveling with a velocity of 4 v0 divided by 3 here. So now again this 2m, it will come and collide with this ball which is in rest position. So now this will become my second collision. Now if I calculate the final velocity of this 2m after collision, then I can calculate like this. So again v1 is equals to m1 minus m2 by m1 plus m2 into u1. So mass is 2m minus mass of second ball is m divided by 3m. Now its initial velocity is v0 divided by 3. So which is equals to, so this is 1 by 3, so v0 divided by 9. So this will be the final velocity of this first ball after collision. Now similarly I can calculate v2 also, that is final velocity of this target ball after the collision. So v2 is equals to, now directly I can use this relation because here u2 is 0, so definitely I can use this relation. So 2 into m1 is nothing but 2m divided by 3m into, now its initial velocity before collision was how much? V naught divided by 3. So that if I substitute, this is V naught divided by 3. So this will become 4 V naught divided by 9. So now the velocity of first target ball after the second collision is 4 V naught divided by 9. So this is again an elastic collision. So this ball will give its velocity to the second ball and it will stop. Second body, now it starts moving with a velocity of 4 V naught by 9, and this second ball cannot collide with the third ball now, because third ball is already traveling with a velocity of 4 V naught by 3, which is a greater velocity, and 4 V naught by 9 is a lesser velocity. So second ball cannot collide with first ball. Now if I write again the final velocities, then these are my final velocities. So this is 2m, which is traveling with a velocity of V naught by 9 after the second collision. And first target ball, again it has come into rest position because it has given its velocity to the second ball. Second ball, now it is started traveling with a velocity of 4 V naught divided by 9. And third ball, it cannot collide again because already its velocity is greater, which is 4 V naught divided by 3 here. Now the first target ball, again it has come into rest position. So again this 2m, it will come and collide with this first ball. So therefore again I can calculate v1 is equals to m1 minus m2 divided by m1 plus m2 into u1. So that is v naught divided by 9. So v naught divided by 27. So after collision, velocity of this ball will become v naught by 27. Similarly I can calculate v2. So that is final velocity of this first target ball, which was in rest position. So for this one, again I can use this relation 2m by m1 plus m2 into u1, because u2 is again 0. So therefore 2 into 2m divided by 3m into, so initial velocity of this first 2m was v naught divided by 9. So this is equals to 4 v naught divided by 9 3s are 27. Now this first target ball, it starts moving with a velocity of 4 v naught by 27. Now it cannot collide with the second ball because its velocity is 4 v naught by 9, which is a greater velocity when compared to 4 v naught by 27. So therefore the final velocities I can draw is this. So 2m, it is traveling with a velocity of v naught by 27. First target ball, it is traveling with a velocity of 4 v naught by 27. Second target ball, it is traveling with a velocity of 4 v naught by 9. Third target ball, already it is traveling with a velocity of 4 v naught by 3. So these are our dear students. Now let us see the second question. So n identical spheres of mass m are suspended with weights of equal length. So first sphere is taken to a particular angle and it is released. So this will strike the second sphere with a velocity of u. Then find an expression for velocity Vn of the nth sphere immediately after collision with the adjacent sphere. So for all collisions, the coefficient of restitution value is E here. So that we are supposed to find out in this condition. So that is the equation for final velocity of this nth sphere after collision with the adjacent sphere, that is the sphere before that one. So this problem we can solve by using the law of conservation of momentum as well as coefficient of restitution, or directly we have calculated equations for any final velocity of first sphere and second sphere if collision is inelastic. So those equations we will write here. So the final velocity of first body is equals to m1 minus em2 divided by m1 plus m2 into u1 plus 1 plus e into m2 divided by m1 plus m2 into u2. So this is the final velocity of first sphere, that is this sphere after collision. So v2 will be, so m2 minus em1 divided by m1 plus m2 into u2 plus 1 plus e into m1 divided by m1 plus m2 into u1. So we are interested only in final velocity of a second ball that is the target ball only, because after all the collisions, so nth ball also will become the target ball for the sphere before this nth sphere. So V2 will be equal to, this total term will become 0, because all these balls before they were in rest position before collision. So therefore I can write this equation will become 1 plus E into m divided by 2m into u1. So u1 is nothing but u. So because initial velocity of first sphere before collision was u. So therefore m and m gets cancelled. So 1 plus e by 2 into u. So this is the final velocity of a second ball after the first collision. Now this second ball, it will take this velocity and it will strike with the third ball. Now that velocity also I can calculate by using the same relation of V2. So V2 is equals to, so again I will write this same equation. So 1 plus E into m divided by 2m, and now u1. Now what is u1? Final velocity of second ball will become the initial velocity of this second ball in collision between sphere 2 and sphere number 3. Now this second sphere, it was having a velocity of 1 plus e by 2 into u. So that will become the initial velocity of the first ball in these two collisions. So therefore instead of u1 I will write this velocity, which is 1 plus e by 2 into u. So m gets cancelled. So therefore I will get, so 1 plus e by 2 whole square into u. So this is a final velocity of third ball. This is the final velocity of second ball. So here I have 3, here I have 2, here I have 2, here I have 1. So therefore by symmetry what can I write? I can write the final velocity of nth ball should be equal to, so 1 plus e by 2 power n minus 1 into u. So this should be our expression for final velocity of nth ball after collision with the ball which is adjacent to the nth ball. So let us see the next question. So two identical balls A and B lie on a smooth horizontal surface which gradually merge into a curve to a height of 3.2 meter. So ball A is given a velocity of 10 meters per second to collide head-on with ball B, which moves on the curved path. So what is the minimum coefficient of restitution for collision between A and B in order that ball B reaches the height C of the curve? So if this ball B should reach this height, then what should be the coefficient of restitution between collision of these two balls that we are supposed to find out? So first we can very easily solve this problem. If I can calculate the velocity that is required for ball B to reach a height of 3.2 meter, and that velocity for that equation we have, so maximum height reached is equals to h is equals to u square divided by 2g. And this is an inclined plane, then how we are able to take u square by 2g, which is the equation for vertical motion. So this is a smooth curve, and to travel on a smooth curve, work done due to friction will be 0. So by law of conservation of energy, work done by gravitational force depends only on the initial point and final point. It doesn't depend on the length traveled by the body. So therefore, and V I can calculate, V is equals to square root of root 2g into h. So body should have this much of velocity so that it can travel to a height of h. So V is equals to, so square root of 2 into 10 into h is 3.2. So this is equal to root 64. So therefore V is equals to 8 meters per second. So therefore this is the first ball, this is the second ball. So therefore the final velocity of a second ball should be 8 meters per second. Then only this ball can travel minimum to a height of 3.2 meters. And because this is an inelastic collision, already we have calculated equations for final velocity of first ball and second ball after collision. So therefore V2 can be written as, so m2 minus em1 divided by m1 plus m2 into u2 plus 1 plus E into m1 divided by m1 plus m2 into u1. So this total term, it will become 0 because initially this ball B was in rest position. So therefore V2 is equals to, so 1 plus E into m divided by 2m. They are identical balls, so instead of m I am writing m. So instead of m2 I will write m only, so m plus m will become 2m. And initial velocity of the first ball was 10 meters per second. So therefore V2 already we have calculated, it is equals to 8 meters per second. So 8 is equals to 1 plus E, m gets cancelled, so divided by 2 into 10. So 2 ones are 2 5s are. So therefore 1 plus E is equals to 8 by 5. So therefore E is equals to 8 by 5 minus 1. So 8 minus 5 by 5 is equals to 3 by 5. So therefore the coefficient of restitution minimum should be equal to 3 by 5. Or if E value is greater than 3 by 5 also, then also the body will travel to a height greater than 3.2, because we know that for elastic collision E value continuously increases. That is, we can say that as collision approaches to from inelastic to elastic collision, E value continuously approaches to unity, that is 1. So therefore E value can be greater than or equal to 3 by 5, so that this ball can reach to a height of 3 by 2. So that is so now let us see the next question. A smooth ball of mass m is suspended from a light string of length 1 meter. So this is a length of 1 meter. Another ball of mass 2m strikes the ball of mass m with a horizontal speed of u is equals to root 35 meters per second. The coefficient of restitution is E. The string becomes loose when it makes an angle of 30 degrees with the horizontal. Then find out the value of E that we are supposed to find out here. So in this condition, so what is meant by string becoming loose? It means tension becomes 0 after covering an angle of total 90 plus 30 is equals to 120 degrees. And in vertical circular motion already we have studied equation for tension for any angle theta. So T is equals to mu square by L minus 2mg plus 3mg cos theta. So this is the equation of tension for any angle of theta. So here at an angle of 120 degrees tension is becoming 0. So therefore 0. And m is mass of this body, which is m. Its initial velocity I don't know, so let it be u square. Length is 1, so divided by 1 minus 2 into m into g value is 10 plus 3 into m into 10 into cos 120. So this total is 120. So cos 120 is minus 1 by 2. So m and m gets cancelled. So therefore 0 is equals to u square minus 20. So 2 ones are, 2 5s are here. So minus 15. So therefore u is equals to 15 plus 20 is 35. So root 35 meters per second. So it means that after the collision, this ball is gaining a velocity of root 35, so that after reaching an angle of 120 degrees, its tension is becoming 0. So, but velocity of first ball is also 35, but its mass is 2m. So therefore I can calculate the coefficient of restitution if I can calculate the final velocity of second ball. So here in the collision, this is my first ball and this is my second ball. So final velocity of second ball after collision, already we have discussed equation about this one in elastic collision. So m2 minus E into m1 divided by m1 plus m2 into u2 plus 1 plus E into m1 divided by m1 plus m2 into u1. So this total term, again it will become 0 because u2 is 0. What is u2? This is the initial velocity of second ball. Before collision it was in rest position. So therefore if I calculate v2, so it will be equal to, so 1 plus E into mass of the first ball is 2m. So divided by 2m plus m is 3m into u1. So initial velocity of this is u1 initial velocity, first of all is u here, so I will substitute u in this condition. So m plus m is getting cancelled, so therefore I will calculate v2 in this condition. So v2 is equals to 1 plus e into 2 by m into u. So this is the equation. This is not m, this is 3 in this condition, so 2 by 3. Now what is this v2? This is final velocity of second ball after collision. So that already we have calculated, which is equals to root 35. So this should be the velocity of this ball, so that after reaching an angle of 120 degrees its tension should become 0. So therefore v2 is root 35 is equals to 1 plus e into 2 by 3 into u. So this is initial velocity of the first ball before collision, which is nothing but again root 35. So root 35 and root 35 gets cancelled. So what I will get? I will get 1 plus e is equals to 3 by 2 is equals to 1.5. So e is equals to 1.5 minus 1 is 0.5. This should be our